Hi, my name is Jennifer Nishimura. I am here with Marissa Hunter, filming for EGR 329, Computer Architecture. We're going to go through these different test cases here, starting with 1100. And then we're going to put the input. We're going to have a single rising edge. You can see it outputted. I'm going to go and it turned off and it stays the same. Then we're going to flip these bits to do 0011. Do the same thing. You can see that nothing outputs because it's not primed into the AND gates. Turn it back on and now it works, or it outputs now. Now we're going to do 1010. Turns on. You get the expected output of 1010. And then it stays the same when we turn W8 off. Now we're going to move on to the next one. We're going to wait. Okay. Here's the 4 to 8-bit register. We're going to write first 4 ones, then zeros. This on, you can see the output is as expected with the ones and the zeros. Next, we're going to write the opposite to the register. WS equals 0, single rising edge. You have the output. Expected output of 10, 10, 10, 10. Okay, now I'm going to turn it over to Marissa.
All right, now we're going to look at the next piece and test those cases, which is the 8x8 memory bank. Let me get in here. This one required a lot more wiring, so it looks a lot messier, but we have all the cases here. These are our inputs here, these are our outputs, and we have some more inputs on this side. The reason these wires are red is because they haven't been declared yet, in a sense. We haven't programmed it to a certain value yet, so it's red. But once we program these, it will, it will not be red anymore. So there's no issue with the wiring in this. Okay, we're going to start with the writing 000001. And we are going to write that to register 0, which is over here. So register 0 is already programmed. So we're going to do chip, we're going to do on, off, and now that programs the register 1 to be this input, the I7. Okay, and then to register 1, I'll go to register 1, which is A0. We're going to program this into register 1, and so we're going to flip the chip again. All right, we programmed it. Now we're going to go to register 2. We're going to program I5 into it. Flip the chip. All right. Register 3, we're going to program that one into it. Flip it there. 4 will be A2 here. Sorry, it's kind of small, hard to read. We're going to program I3. Program that in. In register, that's register 5, we're going to program it with 001, and the rest zeros. chip there. Register 6, our second to last register, we're going to program here. And then register 7, we're going to put in 1 0 0 0 0 0 0 0. Hope I said the right amount of zeros. All right, now everything is programmed, so nothing should show up red anymore. So now we are going to read the registers, and how we're going to do that is click on the read. We shouldn't need any of these inputs anymore because this has all been programmed. All right, so we're going to read register 0, which is what we have here. So I'll flip this, and then we'll come over here and look at our outputs. Here, I'll zoom out so we can do both at the same time. We'll remember the cases, so we won't need that anymore. Okay, so clearly register 0 has the output that we programmed it with. We programmed it with I7, and it is outputting D7. All right, now we're gonna flip this down. We're gonna go to register 1, has output of 1 0 at the end, which is what we wanted. Register 2 has a 1 in the 3rd spot, which is what we programmed. Register 3, a 1 in the 4th spot. Register 4 has a 1 in the 5th spot. Register 5 has a 1 in D2, this spot right here. Register 6 in the 2nd to last spot, and register 7 in this last remaining spot here. So this shows that all our test cases work. We are able to program it and then see the outputs. All right, lastly, we are going to go to our problem 256 memory bank, which is very similar with the exception that there is now multiple of these 8x8 memory banks, and we get to choose which one we are programming. And so these, these ones tell us which chip we are programming, while A2, A3, and A4 tell us what register in the 8x8 memory bank we are going to be using. Okay, so let's start. So we're going to write 001, or 0000001 to register 0 of memory chip 0. So this is memory chip 0. This is register 0, and we're going to write a 1 to it. And this right here shows the hexadecimal. So just for your knowledge. All right, and we program it, and it is good. Now we're going to program chip 0, register 1. Chip 0, register 1 with this value, with the 1 in the 2nd position. All right, that should be programmed. All right, next we're going to program register 2 of chip 1. I believe, I think I memorized these from last time. Yeah, okay. So we're going to program them here. All right, we're still on chip 2, or no, chip 1, because it starts with 0. And we're going to go to register 3, and we're going to program it with I3. So program there. All right, now we've done 2 there, so we're going to move on to our chip 2, which is this chip right here. We're going to move on to register 4. Yes, register 4. And we're going to program it with I4, not this one. And you can see the outputs are over here. So we're going to program that. We are still in this chip, but we're going to program register 5 with I5. All right, it has been programmed, and now we're going to move on to register, or the 4th chip, using register 6. We're going to program it with I6. And then lastly, we're going to program the I7 into the 7th register of the 3rd chip. Okay, now we don't need any of these. So we're just going to read back what we got, what we programmed in. All right, so we're going to read register 0, chip 0. We get output of D0. Perfect. All right, now we're same chip, register 1. We get an output of D1. Perfect. Okay, we're going to move on to the first chip, register 2. Output of D2. Perfect. You can see, read the outputs in hexadecimal here. Which test did I just do? Okay, yeah, that was the third one. So we're still in this remaining chip, and we're just going to move on to register 3, which gives us output of D3. Perfect. Moving on to chip 2, register 4. Yep, D4 is our output. Perfect. Register 5. Perfect. We're going to go to register 6 of the chip 3, which gives us D6 as the output. And our last case, with all of them on, gives us D7 as the output. This shows the final product in its condensed form, but we have clearly shown that all of the test cases work, and that our 26-bit memory cell works. Thank you for listening.